Hi, welcome to another one of our virtual demos. My name is Elias. I'm an apps engineer at MultiLane. Would have been way cooler if I could actually meet you guys in person and show you our demos live, rather than be sitting here and talking to my iPhone. But nowadays we'll have to work with what we have. So what I want to talk to you about today is one of our latest solutions. It's actually an automated test solution for direct attach copper cables for speeds ranging from 100G up to 800G. But before I dive into that and show you how it works and all of that, let me first give you a background of what motivated us to develop this solution as well as our goal. So with the first 800G cables getting out now, everybody started racing to deploy their products into the market and to start producing at high volume to meet all of the demand. And what's going to determine who gets the biggest market share is going to be the quality, the price, and the supply. And what determines who has the best quality, price, and the ability to meet demand is going to be optimization that is performed at the factory or the production level. Now, everybody knows that creating a prototype is relatively easy. The challenging part, which can be 10 to 100 times harder, is scaling up manufacturing while keeping the same performance that was initially present in the prototype. And some of the reasons for that are, of course, supply chain management, large-scale manufacturing and assembly, and all of the other stuff. But one element that is usually forgotten or undermined by a lot of people is the quality assurance or final testing. And the truth is, there's an undeniable imbalance in growth between the new required speeds and the innovative testing solutions that are supposed to be stocking them. And the result is going to be an increase in test time and complexity and costs to new heights. So sure, if you're in R&D and you need a $500,000 solution network analyzer to develop groundbreaking new technology, that's fine. But if you have 10 or 20 production lines, when you scale up for production, you're gonna have to look for some scalable alternatives. In a high volume test environment, what's important in addition to performance, of course, is going to be throughput, cost, scalability, and size. The more systems you can integrate into your factory and the faster you can test while optimizing reliability and your cost margins, the more demand you'll be able to meet and the more profit you'll be able to make. This is why we have developed this automated test solution, which is called the ML1105, which uses our 3-in-1 BERT, DSO, and TDR instrument called the ML4035, or as we like to call it, the Swiss Army knife of signal integrity. So what this solution will do, it will allow you to automate the testing of direct attach copper cables up to speeds of 800G with a high throughput, low cost, low complexity, and minimal human intervention. So let's dive into that.
Okay, so first things first, let's take a look at our setup and at the instrument that we'll be using. So what you're seeing here in front of you on the screen is the ML4035. It's a 3-in-1 BERT, DSO, and TDR. You can see here it has 3 rows of 4 differential ports each, and each one of the row will do its own job. The one at the top is the TDR and DSO. The one in the middle is the PPG up to 56, 58 gigabaud PAM4 and NRC. And then the bottom row is the error detector. And let me show you the setup that I have here in the other room. we have two of these 4035s. So the one on the right is our old box, and this one here is the new version. It's currently getting, it just got released and it's currently in production. And these are two of our 112G MCBs, OSFP, with an 800G cable. So you can see that we are measuring in one direction only. And if we want to measure in both directions, we would require two other boxes, and then we'll be able to cover all ports all at once. So our solution can be, I mean, the customer can choose either a unidirectional solution or bidirectional. So before we get into this automated software, let me first show you the standalone software that comes with it. So this is it, and you can see here the three options to choose from, either the BERT, DSO, or TDR. So we're just gonna go over it quickly. Let's do TDR. So you can see the different options. You can either choose to measure the impedance profile or the insertion loss, return loss, or crosstalk. Let's do impedance profile, for example. You can choose up to 4 channels. Let's choose channel 1 and, I don't know, channel 3. And the setup is the one that I just showed you, the 800G DAC with our 112G OSFP MCBs. So let's see what we get. And first, it needs to configure the device to the specific application, TDR versus TDT, or whatever we're using it for. So and we can see here both channels that we've chosen. We have the different options to choose from. We can add markers, for example, and then this marker would show us, these two markers could give us the difference in time between those 2 points that we've chosen. And also, if we go to the additional settings, we can select specific velocity of propagation, which would allow us to convert this time measurement into actual measurements in meters. We can choose to add some averaging, say 5. Okay, we can run it continuously or just take one snapshot. We can save the measurements as CSV, and we can load another. If we want to compare it to other measurements, we can also load it to the same GUI. Now here's going to be where you change the settings on your display, all of that, but really I don't want to get into the details too much. So let's go to the automated GUI, YAML 1105. So anyway, we can choose here the number of channels per DUT. We're testing an 800G cable, so we're going to choose 8. This is where you select all boxes. So of course, for a full solution, we need to have 4 boxes working at the same time. But one other option would be a unidirectional solution, which is what we're going to do. And we check this box. We type in the IPs of both of our instruments, and you connect. So the first step is going to be choosing the specs that we want. So we have some spec-defined mask that we can choose from, and we can also use our custom mask and modify it. So we choose either one side or 2 sides. I'm just gonna choose one side. If we choose two sides, then we'll be able to flip the DAC if we only have one box. So I'm not going to do that. And next step would be choosing the measurements that we want to perform. So I'm going to go ahead and choose the insertion loss, the crosstalk. COM is going to take some time. So as you know, COM is a very computation hungry algorithm, if you want. And computing that for 8 channels is going to take some time. We have optimized it with our software, and we run all of them in parallel in different threads. So it saves time, but it is going to take around 5 or 6 minutes for 8 channels. So I'm just going to skip that for now. We can choose to save the results, saving the S2P files, the XLS graphs, and the table that we'll get in the end. Because as you know, this software will generate a report in the end with the pass or fail criteria. And in our advanced options, we can choose a number of averages. We can also de-embed. If we want to de-embed our MCBs, we can do that right here. So at this point, we would be entering the serial number of our cable. I'm just gonna go with the, I don't know, 42. Manufacturing number, let's say, I don't know, 9. And either at this point we'll have to run the calibration or load a calibration file if we have already saved one previously. But what I'm going to do, since I already performed the calibration beforehand, is just use the previous calibration. Here we can choose the masks or the tests that we wanna measure against. We can do ILD, IL fitted, or just the loss at Nyquist. I'm just gonna select everything. Yeah, had I chosen return loss, I would also have the return loss spec here to select as well. But right now, let's just do the insertion loss and crosstalk. So I'm going to go here. This is where it shows you the connections. Basically, it will tell you which ports to connect to the TX, which ones to the RX, stuff like that. So just press confirm, and now it's just going to go ahead and do its job. You can see at the bottom left, it's measuring the insertion loss and the far end crosstalk on all of the 8 channels. And once it does that, it's going to start saving the results before it gives us the indication of whether it passes or it fails. So now it's already done with the measurements. It's really, I mean, it's really fast, and it already started saving them to Excel files and the images, screenshots. And this is what takes a bit of time, because you're actually writing those large documents, saving them. But if throughput is the most important thing, you can reduce the number of outputs that can be saved, like images or screenshots and all of that. So now the software will ask you whether or not you would like to test another cable, and if the answer is yes, it will take you back to the serial number and the product number window where you could input the serial number. Or if you have a barcode scanner, by the way, I forgot this to mention this. If you have a barcode scanner, you just scan it, and it will automatically populate everything just to make everything faster. So I'm just gonna say continue, and here you can see we have all 8 channels passing within the 802.3 CK spec for the insertion loss, and then we can check the measurements. Check each one on its own if you want. Okay. And then it will ask you if you would like to run again using the same settings, or if you want to change something else, the calibration or in the mask type or any of that, or otherwise you can just exit. So I'm just gonna show you the output here. So this is the one we saved, side 1. So you will have a folder for each of the 8 channels with the S2P files saved there. That's one thing. Then we will have the automation results. This open. Yep. Okay. So got this saved as well. And then we have the insertion loss and the crosstalk, and we also get an Excel report of our measurements. So we're also going to be adding a PDF report, but for production, I think what's most important is Excel, insertion loss deviation, far end crosstalk, the ICN. So yeah, thank you all for listening and for watching this virtual demo. If you're interested, please go ahead and scan this QR code. It will take you to our website, to the section where it talks about the ML4035 and our solutions, cable testing solutions. I also recommend watching my colleagues' demos. There are some really interesting ones, including one from my colleague Hani talking about Thunderbird, our new GUI for all of our birds. And very soon it's going to also be integrated on the ML4035. So that's really, really good stuff. Very excited for that. And yeah, thanks again, and enjoy your show.